In this section, we're going to be talking about piecewise functions. And by definition, a piecewise function is made up of two or more functions. Now, here's the most important part. Each with its own domain. Now, whenever I think about piecewise functions in real life, one specific example comes to mind, and that's cell phone usage. To where, think of it like this. If you've got a cell phone, and let's say you've got maybe 15 gigs of data on your cell phone. As long as you stay under 15 gigs, then they're not going to charge you extra. You pay one flat rate. However, as soon as you go over, as soon as you have 16 gigs, 17 gigs, they charge you at a different rate. So therefore, from 0 up to 15, you're fine. But as soon as you go above 15, then your rate changes and you have a different function. Well, that's how piecewise functions work. Notice on number one, let's look at some of these. This is what a piecewise function looks like. Here's your function. F of x is equal to both of these, but it's equal to the two of them, all depending on what your x values are. If your x value is smaller than -2, then you're going to plug into this function. Same way with the example I gave you. As long as your gigs was between 0 and 15, you were fine. If you're less than -2, you're going to plug into this. If you're greater than -2, then you're going to plug into this. If you're less than between 0 and 15, in my example, then you had a certain price. Then if you went over 15, then you had a different price. So the if over here tells you which function or which part of the function that you're going to plug into. So to find f of -5, to plug -5 in, well, the first question is you've got to ask yourself, where does that fall? Is that less than -2 or is that greater than or equal to -2? And we know that that -5 is less than -2, so we're going to use this part. So f of x is equal to this if you're less than -2. So therefore, to find f of -5, we're simply going to do -5 squared minus 1. We're going to plug it into that. And that's going to be 25 minus 1, which is 24. To find f of -2. Now, that one's a little bit tougher because where does -2 fall? This one's smaller than -2. This one is greater than or equal to. Notice the or equal to here. So therefore, we're going to use this part. We use this function if we're greater than or equal to -2. So we're going to do 5 times -2 plus 3. We're going to take out the x, plug in -2. That gives me -10 plus 3, which is -7. To find f of 7, again, ask yourself, is that less than -2 or greater than -2? Since it's greater than -2, we're going to use this. And to find f of 7, we're simply going to do 5 times 7 plus 3, which is 38. Okay, number two. Number two says g of x is equal to this stuff. It's equal to this if you're smaller than -4 or equal. It's equal to this if you're between -4 and 1. And it's equal to this if your input is greater than 1 or equal to. So the first one asks us to find g of 2. So we ask ourselves, where is that? We know that 2 is greater than 1. So therefore, we're going to plug it into this. So we're going to do 2 times x to the third plus 9. So take out the x, put in the 2. That's going to be 2 times 8 plus 9. That's 16 and 9, which is 25. B part says find g of -1. So again, ask yourself, where is -1? And we know that -1 is between -4 and +1. So therefore, we're going to plug it into this part. So g of -1 would be negative, take out the x, and plug in -1. So you have -1, which is +1, minus 1, which is 0. And finally, g of -6, C part, we ask ourselves first off to plug in -6. Where is -6? We know that negative 6 is less than or equal to negative 4, so we're going to plug it into this part. So we're going to do 1/2 x plus 3 would be 1/2 x plus 3. Half of negative 6 would be negative 3 plus 3, which would be 0. Okay, well, number 3, we're going to start graphing piecewise functions. So the graphs, we can actually do t-tables for these. However, notice something about your t-tables. We're going to do a t-table for each part. We're going to plug in values here that is less than or equal to negative 3. That would be values like negative 3, negative 4, negative 5, negative 6. And then for the second part of our graph, we're going to plug in values greater than negative 3. So that would be like negative 2, negative 1, 0. Whoops. Negative 2, negative 1, 0. Now, do this for me, though. I also want you to plug in negative 3, and I want you to understand that that's going to be an open circle there. Okay, that's not going to be part of your graph, but that's where your graph starts, and you'll hopefully understand a little bit more as we go through this. So the first thing we're going to do, we're going to take these red values, and we're going to plug them into the first part of our function, which is just x. So when x is negative 3, f of x is equal to, just plug in negative 3, you get negative 3. Plug in negative 4, you get negative 4, and same thing, and same thing, and same thing. The blue part says when x is greater than negative 3, we're going to plug it into this part of our function. So when x is negative 2, we're going to do negative 2 times negative 2, which is 4, plus 1 is 5. Negative 2 times when x is negative 1 be negative 2 times negative 1 is 2, plus 1 is 3. And let's go ahead and finish that graph out. And here's what you get. Negative 6 and 1 is 7. So the red part of my graph, let's plot some of these. You have negative 3, which is a dot here. Negative 4, which is a dot here, here, here. And you see that's linear. That's going to be, if you were to do y equals mx plus b, this line has a slope of 1, a y-intercept of 0. However, this graph is only to the left of negative 3. So let's connect my dots. Now, the next question is, could I have plugged in values further to the left? Could I have plugged in negative 7, negative 8, negative 9? And sure, so what I'm going to do, I'm going to put an arrow on that part of my graph. Now, let's go to the blue part of my graph. Negative 2, 5 is located right here. Negative 1, 3 is here. 0, 1 is here. And that's also a linear graph, and you can see that y equals mx plus b, slope is negative 2, y-intercept is 1. We could have plotted it like that. Now, there's something about that negative 3, though. Let me remind you what I said. That's where your graph starts. However, negative 3 is not part of your graph. So here's what we're going to do. At negative 3, 7, we're going to go left 3 and we're going to go up 7. I'm going to put an open circle. And the reason for that is my graph starts at negative 3 and it continues to the right. Let's scroll back up. So I'm going to start at negative 3, go to negative 2, negative 1, 0, and continue on to the right. And I could have plugged in values further to the right of that, and that's what your graph looks like. You have a solid circle here. This is a function, by the way, because you have a solid circle here, but right above it, you have this open circle up here. Okay, so there's no points above points. So this is what your piecewise function looks like. Now, there's actually a second way that I'm going to demonstrate how to graph these. Here's another way of thinking of it. Let's graph each of them. Okay, let's graph both of these values. Let's start with y equals x. We're going to graph it, and then we're going to graph y equals, we'll do it in a different color. We're going to graph y equals negative 2x plus 1. Okay, let's start with the red one, y equals x. If you don't remember, that's since slope-intercept form has a slope of 1, a y-intercept of 0. So we're going to start here at 0, rise 1, run 1, and our graph would look something like this. Connect the dots, and you've got a linear equation. Let me connect them. And there you go. But there's an issue. We only want to graph this. Let me change. We only want to graph this here. Now, where is x equals negative 3? It's here. Here is where x is negative 3. So we only want to graph that portion of our line, if you remember inequalities, left of negative 3. We only want that portion of the graph, scroll back up, we only want that portion of the graph left of this line, where x is less than negative 3. So this portion of the graph, I need to be gone. So there you go. Now let's do the same thing for the blue graph. Y equals negative 2x plus 1 has a y-intercept of 1. Let me change. Y-intercept of 1, slope of negative 2. So there's your y-intercept. Go down 2 over 1, down 2 over 1, down 2 over 1. Connect your dots. And your line would look something like this. But again, there's a problem. We only want to graph this greater than negative 3. So that dotted line that I drew a while ago was where x was equal to negative 3. So we only want our blue graph on the right side where it's greater than negative 3. Well, what about right here at negative 3? What happens right here where your x value is negative 3? Well, where it's equal to negative 3, that's not part of your graph, but that's where your graph starts. So that's the reason we did an open circle right there at the negative 3. Which is right here, and then we extended everything. So we only want to graph this blue line to the right of negative 3. So let's erase the part we don't need. And your graph would look something like that. But again, we need an open circle right here. And down here, we'd need a closed circle on this part because it was included. Remember, open circle not included, closed circle included. And I actually should have put an arrow on that side as well. My domain. Now, what all can x be? That's my domain. X can be anything less than or equal to negative 3. It can be anything greater than 3, negative 3. So that would be everything. Your domain can be any value. So that'd be from any value from negative to positive infinity. Now, let's talk about your range. The range is, again, how high and how low does your graph go? There's the highest point. There's no lowest point because your graph goes down forever. So your range would be everything from negative infinity up to this highest point. Now, what is this highest point on your graph? Well, that's whatever you get when you plug negative 3 into the blue part of your graph, which was 7. So this highest point here was this point right here is negative 3 comma 7. However, it's an open circle. So it's not part of my graph. So my graph goes all the way up to 7, but it doesn't include it. So it goes up to 6.99999. Okay. Number 4. Let's graph another one. Y equals negative 3x minus 7. If you want to do it the second method, we only want to graph that to the left of negative 1. So if you want to go ahead and put your parameters, here's the negative 1 line. Your first part of your graph, you're only going to plug in values smaller than this negative 1. So you're going to plug in like negative 2 and negative 3. For the second part of my graph, we're only going to plug in values greater than negative 1 or values to the right of this negative 1. So you can do the slope intercept again, and we can just erase the part we don't need. So let's graph y equals negative 3x minus 7. So that's going to be 1, 2, 3, 4, 5, 6, 7. We need a slope of negative 3, so we need to slant downhill. So it's going to look like this. But here's the thing. We only want to graph this less than negative 1. So we're only going to graph this part on the left side. Keep scrolling down on accident. We're only going to graph this on the left side of this line. So what about right here, this dot that I've got on it? Since it's not or equal to, that's not going to be part of your graph. So we actually need to do an open circle right there. And we're going to graph everything to the left. So when x is less than negative 1, that's what my graph looks like. This over here I don't need anymore. What about when we're to the right of negative 1? Well, then my graph looks like this. It looks like y equals negative 5. Well, what is y equals negative 5? What's that look like? That's going to be a horizontal line. Negative 1, negative 2, negative 3, negative 4, negative 5. So let's go down to negative 5 on my y-axis. And my line is going to look like this. Now, normally my line extends forever left and right. But we're only going to graph this line to the right of this negative 1. So we're going to start at -1. We're going to put a closed dot because we include -1. And we're going to draw that horizontal line to the right of there. Now, what is my domain? What values can I plug in? I can plug in any value smaller than -1 or any value bigger than -1 or equal to -1. So that's everything. My domain, I can plug in any value, which means my graph, if you look at it, should extend forever to the left and forever to the right. Now, what are my y values on my graph? Now, this one's a little bit tricky. My y values, if you notice, start down here and start moving this line up. And you hit graph when you get to this y value. So one part of my range would be this y value, which is -5. But something weird happens. Then it jumps. There's no graph between here and here. If you'll look real close, there's nothing there for those y values. So we go from -5. Let me try to zoom in here a little bit so you can see it a little bit better. We go from -5 on my graph, and then we jump up to -4. And even though -4 is not included, there's nothing, again, no graph between -5 and -4. And then my graph starts at -4, starts back up, and it continues up forever. Here's how we're going to write this. We're going to write this in set builder notation. My range is the set of all y's such that y is either equal to -5 or, remember the union symbol, y are values greater than -4. So y can be one or the other, either, and you could write this, honestly, you could just give me this part and I would mark it right. Y is either -5 or -4 and above is what that says. Number 5, your division line is going to be 2 on this one, x equals 2. So right here at 2, this is where you're going to graph the first part to the left of this 2, and you're going to graph the second part to the right of this 2. And again, that's not part of your graph. I'm just putting that as a dividing line. The first part of your graph, y equals -5 halves x minus 1. So you have a y-intercept of -1. You have a slope of -5 halves. So go down 1, 2, 3, 4, 5, and over 2. Or go up 1, 2, 3, 4, 5, and left 2. There's the first part of your graph. Now we're only going to graph that to the left of this red line. So what I'm going to do, this is not going to be part of your graph because it's not or equal to. So I'm going to do an open circle at that, and I'm going to just draw the line from there. So there's the first part of your graph, and you can put an arrow on it. And again, the reason for the arrow is you can plug in any value less than 2. So that graph continues on. The second part of my graph is y equals x plus 2. Let's do it in a different color. So my y-intercept is a positive 2. I have a slope of 1, so up 1 and over 1. It's going to be this line. You could go down 1 if you wanted to, but we're only going to graph this for values bigger than 2 or values to the right of this red line. So honestly, I'm not going to need this point or this point because I'm only going to graph points to the right of this line. Now, what about on the line? If 2 is not included, I'm going to do an open circle, and my graph is going to start there and continue to the right. So again, you can erase this dotted line now if you want to. I graph the blue line to the left of that dotted line. I graph my red line to the right of that dotted line. So there's my graph. So something odd happened at 2. Notice that 2 is not included on either graph this time. So when we're talking about domain, the domain would be all values from, let's just write it in interval notation this time. All values from -infinity up to 2, not including 2. Or any value from 2 to infinity, not including 2. So that's a funny way of saying x isn't 2. X is everything except for 2, but x is not 2. Now let's look at your y values for your graph. Your graph starts here. Starting at the bottom, your graph starts here. But it does not include this y value. That's 1, 2, 3, 4, 5, -6. Your graph starts at -6, but it does not include -6. And it looks like it continues up forever. -5, -4. There's graph everywhere right here. You've got 2 points of y values there, but the graph continues on forever in the y direction. So therefore, there's no other breaks in your graph. So it goes from -6 to infinity. If you want to write that in set builder notation, that'd be the set of all y's such that y is greater than -6. Notice that we're not including -6. So you can write it either way, or you could just say y is greater than -6 is your range. Any of those would be fine. Next one. Okay, you actually have two division points on this one. To the left of -5, you're graphing this. Between -5 and 1, you're graphing this. And to the right of 1, you're graphing this. So let's draw us a line at -5 and at 1. And I'll just do a solid line here. And again, the reason we did that is if we're going to plug in values to the left of -5, we're going to plug it into this first equation. So we're only going to use that. If we're going to plug in values between -5 and 1, we're only going to plug it into this. If we're going to plug in values that are greater than 1, which is over here, we're only going to plug it into our last one. So if x is less than 5, we're going to graph y equals -1. If you don't remember y equals -1 or g of x equals -1, that would be a horizontal line. So go down to -1, and let's draw a horizontal line. Something else, here's -1, by the way. So this is going to be that horizontal line, but we're only going to graph that horizontal line to the left of -5. Now, what about or equal to? That means at -5, you're also going to do a closed circle, and there's your horizontal line. Okay, between -5 and 1, we're going to graph this line. Well, let's graph it everywhere. Y-intercept's -3. Your slope is -1, so you're going to go down 1 and over 1, down 1 and over 1, down 1 and over 1. You're going to continue that on. It's going to look something like this. And I'm doing extra points just to show you. I only want this graph between -5 and +1. So anything outside of that, we're going to have to delete like that. Now, if you'll look a little bit closer, I'm not going to include -5, and I'm also not going to include 1. So these two dots that were here, oops, I need that line back. And the dot that is here, I've actually got to do open circles because those points are not going to be included on my graph. And then I simply connect my dots. Okay, and then to the right of 1, I'm going to graph the line y, or g of x, equals 6. So that's going to be a horizontal line as well. So we're going to go up to 1, 2, 3, 4, 5, 6. And from this point to the right, I'm going to graph that horizontal line. So there's your graph. So all depending on what, and you can take the red lines away now, all depending on what your domain is, what your x values are, that's what your graph would look like. Now let's talk about what my domain and range are. Okay, my domain, let's start over here and start tracking to the right. And I have graph everywhere from -infinity up to, you notice even here and here, I'm still hitting graph. I hit this point right here. Here, I'm still hitting graph. And even when I get to here, I still hit graph. And there's nowhere that there's a break in that graph. There is graph everywhere from -infinity to +infinity. Now, what's another way of looking at that? You graph this everywhere smaller than -5. You graph this between -5 and 1, and you graph this to the right of 1. So that covers every x value. There's no breaks in that graph. However, there is breaks in your range. There's no graph down here. And your graph only starts here. And it starts with an open circle. Now, what is that y value? That's y equals -1, -2, -3. That would be a y value of -4. So your graph starts at -4. And then it goes up to, there's graph here, there's graph there. It stops here at a y value of 2. And notice it stops on an open circle there, so 2 is not included. Union, and then your graph starts back up at this horizontal line here. And there's only one y value on that horizontal line, and it is 1, 2, 3, 4, 5, 6. So the only other point on your graph would be the number 6. So you have all the numbers between -4 and 2. union the number 6. It's not 6 to 6 or anything like that. That's a single y value there, so you're just going to put union 6. Okay, number 7. Number 7, first off, let's find our parameters. Where are our x values located? We're graphing the first section left of -2, second section between -2 and 4, and then to the right of 4. So I'm going to draw me a line at -2 and 4 to divide my graph into sections. Okay, now the first portion of my graph says to graph this to the left or less than or equal to -2. Now I do want to point out also that we're going to include the point at -2. So we're graphing y equals 2x. There's no y-intercept, so it's understood to be a 0. So y equals 2x plus 0. That would be, let's see, y-intercept is here. Now we can start to get into this habit. Let's put an open circle here because this is actually not going to be part of our graph. My graph, I'm only graphing y equals 2x over here in this first region, everywhere x is less than -2. So let's use that slope and let's rise 2 and run 1. If I were to go this way, that's not going to be on my graph. Rise 2 and run 1, that's not on my graph. Now what about here at -2? Notice that we're doing less than or equal to, so we are going to include this point right here. We're including this point, we're including this point. So my graph at y equals 2x looks like, or from -2 to the left, looks like this. Now I can go back and we can erase these points that were not included. The middle portion of my graph looks like this. Y equals, and I'm going to erase 2x and I'm going to put in its place. It says -1 minus x. I don't like that. To get it in slope intercept, let's write it as -x minus 1. Where we can see that my slope is -1 and my y-intercept is -1. And we're going to graph that in this middle region. So I'm going, y-intercept is -1, and that is in the middle region, so I'm going to include it. I'm going to go downhill slant, that'll be right 1, down 1, right 1, down 1, right 1, and continue on. Or we can go up 1, left 1. Now again, the question is, what do I do at -2 and what do I do at 4? We're not including and we're not including. So I'm going to do an open circle here, and I'm going to do another open circle here. So we're going to graph this line from here to here. Then the last portion of my graph, I'm going to graph y equals -3 from 4 on. Notice that it is included, so y equals -3. That's going to be a horizontal line, so I'm going to come here and I'm going to graph a horizontal line across here. Let's see, we're going to include it at 4, so I'm going to do a closed circle and I'm going to shade everything to the right, or I'm going to draw a line to the right. Now let's talk about domain and range. Was there any value not included? Okay, I graphed this from -infinity up to -2, including -2, and then from -2 to 4, I graphed this, but I didn't include 4, but I did here, and I went from 4 to infinity. So there is absolutely no breaks from left to right in your graph. Even though it might jump, there's no x values that are not included. This -2 value is included here, even though it's not included up here. This 4 value is not included down here, but it is included right here. Now let's talk about the range though. My graph does extend down forever because of this line, so we're going to start at -infinity, and then we're going to move up from there. And I'm going to look for, are there any y values that are not accounted for? This one has a y value here. This one has a y value here. That one has y values here and everywhere over here. My y values stop here. My y values stop at 1, and since it's an open circle, it is not included as well. So therefore, my range would be all values from -infinity to 1. Okay, number 8. Number 8, let's look at our x values to see where what x values we're going to plug into our graph. So we're doing all values left of 0, between 0 and 6, and then all values to the right of 6. So our division points on our domain or on our x-axis will be at 0 and 6. So let's go ahead and do some vertical lines at 0 and 6 as guides. And there we go. In the first part of our graph, we're going to graph this everywhere to the left of 0, or for all x values smaller than 0, which again will be over here as we're going to graph the first part. So we're graphing y equals, and again, here's your y equals -3x. -3x has a y-intercept out here of 0, so we're going to put our y-intercept at 0. But here's the thing, that's on my division line here. So the question is, do I need to include it in my graph or do I not include it? Since here you have less than 0, it's not less than or equal to, let's do an open circle. That means it's not included. Now my slope is -3/1. So if I go down 3, that would be going to the left or right 1, excuse me, to get that downhill slope. If I go up 3, that's going to go to the left 1. And since I'm going to graph everywhere over here, I'm going to go ahead and just include those 2 points, connect my dots, and there's my line. It extends forever. We're done with that portion of my graph. Now let's look at the next portion from 0 to 6. That means I'm going to graph in here. That's the points from 0 to 6. I'm going to graph y equals -1/2 x minus 1. Next question is, do I include 0 and do I include 6? 0, since I have or equal to, will be a closed circle. I'm not going to include 6. So 1/2 x minus 1, my y-intercept is -1, and it's on that line, so I'm going to include it. My slope is -1/2, so go down 1/2, down 1/2, down 1/2 actually lands on this one, and I said that 6 was not included, so I'm going to do an open circle. We're going to connect our dots. And then for the third portion of our graph, over here, for everything greater than 6, I'm going to graph y equals, let me erase this, y equals x minus 7, which means I have a y-intercept of -7 and a slope of 1. Okay, look, am I going to include my values at 6, though? It says x is greater than 6, which is odd. We'll talk more about that in just a second. But we're not including 6 again. My slope is -7. Now I've got to put my slope or my y-intercept way over here. 1, 2, 3, 4, 5, 6. And I'm going to do this. Since that's not part of my graph, I'm going to do an open circle there just to remind me, hey, what I'm drawing now is not part of my graph. Rise 1, run 1, rise 1, run 1, rise 1, run 1. And again, none of this is parts of my graph because I'm only graphing this to the right of this line. So this is part of my graph, this is part of my graph, and all these open circles that were not part of my graph, if you would like to, you can get rid of those now. My graph starts at 6 and goes right forever. So there's your graph now. Now let's talk about domain, and that's the part I said we were going to discuss again because your domain is all things below 0 and then from 0 to 6, including 0 here. So that'd be all things all the way up to 6. And then what happens at 6? I didn't graph 6 here. I didn't graph 6 here. If you'll look over here, there's an open circle here at 6 and an open circle here at 6. 6 is not included. So my domain would be all things from -infinity up to 6, not including 6. And then all things from 6 to infinity, again, not including 6. Now let's look at our range. Where's my graph located left to right? There's no graph down here. My graph does not start until I get to here. And what is here? What do I mean by here? That is a y value of -1, -2, -3, -4. My y values start at -4. However, -4 is not included. See the open circle. And then my graph continues all the way up. It's included here. Now, does it jump from here to here, though? No, because this y value is over here on your graph, so that's included. And this part goes up forever. This part also goes up forever. So I'm going to have graph everywhere up here as well. So that's going to be from -4 all the way up to infinity would be my range.